Hello everyone, welcome to week 7. This is our last week of new material and our last week of school really before summer. So hopefully this finds you well. Hopefully you've stayed on top of your work and you don't have a ton to do this week. Just like the past 2 weeks, there's only one assignment. The videos will be broken down into 2 sections. The first section, today's video, will be talking about naming solids and the volume of prisms and cylinders, right? The second video will be about the volume of spheres, hemispheres, pyramids, and cones. All right, so once again, this video will be about naming solids and the volume of prisms and cylinders. The second video will be about the volume of pyramids, cones, and spheres. All right, so without further ado, let's get started. All right. First thing when we're talking about solids, all we're talking about is we're talking about three-dimensional space or three-dimensional shapes. So now not only do we have a length and a width or a base and a height of a base, but we also have a height. So it's not just flat, it's also coming up or down. All right. If it is made up of all polygons, so all straight segment sided shapes, all right, like triangles, squares, pentagons, hexagons, rectangles, parallelograms, etc., like that, basically not circles, all right, it's called a polyhedron, all right? And then from there, we have three basic parts of a solid that we've all heard before, hopefully. We have the face, which is just one of the so-called sides, is what a lot of times call it, but the better name is face. The edge is where two faces intersect, all right, and the vertex is where two edges intersect. All right, so our vertexes are the corners, our edges are the straight sides, and our faces are each and every flat part, or what we probably would call the sides. All right. Next we have, and from there we can split solids into a couple other different places. All right. The first type of solid we can have is a prism. All right. A prism, all right, has two bases or two congruent bases, all right, that are split up by a certain height. So basically what this statement up there is saying right underneath prism is it's saying, hey, this rectangle right here on this shape, all right, is the result of all of these faces in between. So like if we sliced it, there's an infinite number of slices there between the top and the bottom. All right. Basically, that's a fancy way of saying, hey, we have a base on top, we have a base on bottom, we got all the space in between. That's basically what it's saying. All right. If it's a prism, we have two congruent sides or faces, and they have to be parallel, meaning they have to be going the same direction. All right. Notice this one, it's the one it's setting on. It's those hexagons. This one up here, though, those hexagons are not what it's setting on. So it's whichever one is the same. It doesn't necessarily have to be the top and the bottom. Notice this one, they chose the front and the back. All right. So it doesn't always necessarily have to be the top and bottom. It can be front and back, left and right, depending on where it is. All right. The lateral face, they're basically the faces or the sides that connect the two bases. All right. Almost all of our normal ones will have rectangles for their lateral faces. All right. In a second, we'll talk about what happens if they're not rectangles and they're parallelograms instead. All right. Then we have what is known as the height of a prism, and that's just the distance of a perpendicular segment between the two bases. All right. When it's a normal prism like this, right, it's just that distance right there. All right. For this one, it's that distance right there, since our faces are the front and the back. All right. Once again, height. So it depends. It's between our two bases. It's perpendicular, so it has to be a right angle. All right. Then we have three down here. How we name them is we just take the base. So in this case, it's that shape right there. Well, it has 6 sides, so it's a hexagon. So it's a hexagonal prism because it's a prism. Here, base is a triangle, so it's a triangular prism. There's our base there. It's an octagon, so it's an octagonal prism. All right, then there's 4 for you to try right there. All right, now, occasionally, and we don't deal with these very often, but we have what's known as an oblique prism. All right, and what it means by oblique is that these sides over here, that's a parallelogram instead of a rectangle. All right, these lateral faces, the ones that go on beside, they're slightly shifted to the left or the right so that they're not perpendicular and they're rectangles. What that means, and the reason why we would describe that, is that the height then would be this distance right here. All right, because it has to be perpendicular. All right, the next type of shape, that's it for prisms. The next one we have is pyramids. All right, and basically the pyramids, their lateral faces are triangles. So each one of these right here. All right, we have one base. All right, it's the side that doesn't come up here to a point. That point is called the apex. All right, our height of our pyramid is from that apex point down to a right angle or perpendicular to the base. All right, and then a little other term that we have here is we have what is known as the slant height, which is the height of one of the triangular faces. All right, so the slant height is if we would go up the slant of the pyramid. The pyramid height is if we just went from the top and fell straight down from the top to the bottom. Not sliding down, but fell straight down. That's the difference of those two there. And that'll be discussed a little bit more in the second video. All right, once again, to name a pyramid, notice we're using the word pyramid now, not a prism. All right, we still just name it by the base. So here the base is a triangle, so it's a triangular pyramid. For that one, base is an octagon, octagonal pyramid. Base here is a pentagon, pentagonal pyramid. All right, and then there's 4 for you to try down there. There's just whatever the base is, that shape, pyramid because it's a pyramid. All right, here's just a little bit nice information to know right here. All right, platonic solids. All right, it's a solid that has all regular polygons for all of its faces. All right, there's only 5 of them that we know of. All right, a cube is made of 6 squares. A tetrahedron is made of 4 equilateral triangles. All right, an octahedron is made of 8 equilateral triangles. All right, and an isosahedron, I'm not entirely sure how many triangles that one is, guys, to be quite honest with you. I think it's 1, 2, 3, 4, 5, 10. I think it's 20. I'm not 100% sure. And then a dodecahedron is 12 pentagons. All right, just neat. Those are called platonic solids where they're made of all regular polygon shapes. All right, now we can also have solids that are made of non-polygons. All right, there's 3 main ones of these. First one is a cylinder. All right, a cylinder is basically a prism. All right, except for it is made of a circular base. So instead of calling it a prism, we call it a cylinder. All right, so we have 2 bases. Those are our congruent circles. The height is the distance between the 2 circles, or the distance perpendicular from the 2 circles. And we call that, notice the distance between those 2 circles, that flat part, it's no longer made up of rectangles because the circles are curved. So we just call that the lateral surface, that curved part. If we were to cut it and lay it out, all right, or if you think you've cut a silicone, and I cut it right here on that side right there, and I cut it, all right, I would have the circle from the top, the circle from the bottom, and that lateral surface, if we rolled it all the way out, would be a rectangle. All right, so we'd have that rectangular part in the middle. All right. If we unrolled it from the top and the bottom of the base. All right, but that is a cylinder. It's basically a prism with circular bases. All right. Likewise, a cone is very much like a pyramid, except for it has a circle for a base. All right. The base is the circle from which the lateral surface, once again, the lateral surface is just that curved part. All right. It's no longer triangles because it's curved. If we light it flat, it would look kind of like this. So almost like a triangle, except for the bottom part of it's curved. All right. Our top point is called the vertex. All right. And just like a pyramid, we have the height of the cone and we have the slant height. The slant height is if we slid down the side from the top. The cone height is if we fell straight down from the top, perpendicular to the ground. All right. That's what we need to know about our cone. The last one is a sphere. All right, just like a circle is all the points equal distance from a center in 2 dimensions, a sphere is just a set of all points from all the points the same distance from the center. So every point along the outside is the same distance from that point, but it's now in 3 dimensions. All right, and our distance from the center to any point on the outside is our radius. All right, just like it would be of a circle. All right, so the sphere is just all those points that are the same distance from the center in 3 dimensions to 2 dimensions. If it was 2 dimensions, it would be a circle. All right, so this whole set of notes was just a lot of naming type of stuff. All right, the big takeaways from it: know what a sphere looks like, know what your cone looks like, know what your cylinder looks like, know how to find the base of a pyramid, know how to find the base of a prism. All right, moving on to the finding volumes. We're just going to do prisms and cylinders for the rest of this video, and then pyramids, cones, and spheres will be in a second video. All right, what this first part starts as, all right, is basically showing you how we get the volume equation. All right, since we're now in 3 dimensions, we're taking a whole bunch of flat things and stacking them on top of each other. All right, a good way to think about this is if you've ever looked at a ream of computer paper. All right, now one sheet of paper is not very thick at all. All right, it's basically flat. But if we take 500 sheets of paper, all of a sudden we can measure the height of that stack. All right, so that's basically what it's doing. All right, it's taken one sheet of paper, all right, which we can't really measure the height of, but we can find the volume of a ream of paper because there's 500 sheets together, so it has a height. All right, and as we make that smaller and smaller and smaller, all right, that's how they get the volume formula. All right, so if we have a prism, basically what we're doing is we are just adding the area of each one of these slices. All right, as we get closer though, as we keep slicing, we make them as small as we possibly can, so we don't end up adding anything. We just take the area of the base and we multiply it by the height. So the volume of a prism is the base times the height. Notice this big B though is the area of the base. All right, and the height now isn't the height of the base, it's the height of the prism. All right, so what that means, all right, is if we have this triangular prism right here, our big B is going to be the same thing as 1/2 base times height. It's just going to be the area of a triangle. All right. The height then of the prism, all right, we're going to multiply times that whole thing. All right. So we're technically going to have two heights. All right. We would have the height of this triangle, and we have the height of the whole prism. All right. Guys, most of the time, those numbers are not going to be the same. All right. So we find the area of that rectangle, area of this triangle, and we multiply it by the height. Likewise, for this one, we'd find the area of that rectangle, multiply it by the height. For this one right here, we'd find the area of that hexagon, multiply it by the height. And that's how we find the volume of a prism. All right. A neat little thing that can show us, all right, is that oblique and right prisms, all right, remember oblique is just when we have this parallelogram type side, and right is when it's perpendicular, all right. If the bases are the same and their height's the same, they have the same volume, all right. Even though it might look like that stack takes up more space than the stack to the left, all right, the number of CDs is the same, and they still technically have the same volume. All right, the one on the right just looks like it takes up more space because it's slid over or it's tilted. But their volume, or the amount of space they actually take up, is technically the same. All right, now as we get down here, all right, we just have a bunch of examples. All right, this paragraph up at the top right here is kind of what I was already talking about, big B, what the base area was and what the actual height is, and how we can sometimes have two heights. All right, and we're just going to look at a bunch of examples. All right, this first one is a cube. All right, so the area of the base right here, all right, it's a square, so they take the area of a square. Well, that's 5 times 5, which is that part right there. Then they multiply that by the height, which is 5. All right, multiply that all out, they get 125. Now, since we're talking about volume, length, it's three-dimensional, length times width times height for this cube. So it's centimeters cubed because there's 3 dimensions. Area was dealing with 2 dimensions. Perimeter was just 1 dimension because it was the length around something. All right, but notice square, base times height is its area, so 5 times 5 times the overall height. All right, next one is a triangular prism. So we have this triangle right there. All right, the area of the triangle is 1/2 base times height. Base is 8. Height of that triangle is 5. So 1/2 times 5 times 8. Then we multiply that by the height of the whole prism, which is 10. Notice that's what's going perpendicular on both sides. Multiply by 10. All right, when we multiply that all out, we get 200 centimeters cubed. All right, again on the third one, this one's now a rectangular prism. All right, they decided that to be its base. All right, the area of rectangle is length times width, or base times height, so 3 times 4. Actually, I should have done that in orange to be consistent. All right, and then they multiply it by the height of the prism, which is 12 in this case. Multiplying it all out, they get 144 centimeters cubed. All right, next example, they give you a hexagonal prism. All right, and it's a regular hexagon, so remember that's when we have our formula that is 1/2 times the number of sides times the side length times the apothem, or the apothem times the perimeter times 1/2. All right, that's where they're getting this part right here. All right, in order to do this, they're using a 30, 60, 90 right triangle, so there's a little bit of trig involved there. Don't worry, on your homework you won't have that. All right, but that's how you get that 3 square root of 3. It's using trig. All right, that's their apothem. All right, the perimeter, since it's 6 times 6 is 36, so that's how they get this part. That's the area of one of those hexagons. All right. And the height of the whole prism is 10. So they're multiplying by 10. All right, so just find the area of the base, in this case it's the area of a hexagon, times the height of the overall prism, which is 10. All right, this fifth example, all right, notice it's not one nice looking shape. It's kind of funky. It's got a little part jutting off. So what we're going to do is just like we did with area when we split it up, we're going to cut this shape right here. All right, so we're going to do this little prism. We're going to add it to the rest of the prism. All right. So that orange prism, all right, and I'll explain how they did it first. I would do the orange one is 6 times 4, and the height is 10. So that would be 6 times 4 times 10. All right. The smaller prism is 2 by 2. This distance is still 10. So 2 times 2 times 10. All right. I would do each one of those separately. That's what makes sense in my head. That's 240. And that should be approximately, that should just be equals. All right. The other one is 40. All right. If I add those together, I get 280. All right. What they did is they said, oh, hey, this whole thing is the base. All right. And it has that height. So they put the base here as just, oh, hey, this rectangle is 24. That part's 4. So my whole base is 28, or 24 plus 4, times the height of the prism is 10. And they got 280 centimeters cubed there as well. All right. So it doesn't really matter how you do it. All right. I like breaking it into two separate solids and then adding them together at the end. If you want to find the two separate bases and then add them together and then multiply by the height, that works just as well. All right. So you have options there with prisms. All right. There's 3 for you to try. All right. First 2, you just find an area of the base times the height. Third one, you're going to have to take the triangular prism at the top and the rectangular prism on the bottom left. All right, so whether you do it area of the base plus area of the base times the height, or volume of one plus the volume of the other, up to you. All right, now a cylinder works basically the same way as a prism. We're moving on to cylinders next. All right, sorry, I should have paused a little bit there. All right, except for now, instead of stacking polygons, we're stacking circles. So what we can do for a cylinder is, since it's always a circle, we can rewrite that base area as the area of a circle, which is pi r squared. And we're still going to multiply it by the height. But that base area is now pi r squared, specifically for a cylinder. All right. So coming down here, they have a couple of examples for you. First one, my radius is 4. My height is 5. All right. So we find the area of the base, or the area of a circle, which is pi r squared, or pi times 4 squared. All right. Then we multiply by the height, which is 5. All right. 16 times 5 is 80. Notice they left pi in their answer there, so it was just 80 pi centimeters squared. All right. If they wanted to, you could take 80 times 3.14 and you'd have your decimal answer. All right. Example 2. All right. This time they don't give you the radius. That's your diameter because it goes all the way across. So the radius would be 3 centimeters of that cylinder. But then from there, it's just the same thing. Pi times the radius squared, or pi times 3 squared, or 9 times pi, times the height is 4, gives you 36 pi centimeters cubed. All right. Now, the third one's a little bit tricky. All right. We have this whole part, or this cylinder, cut out of the middle. All right. And we have a big cylinder on bottom with a slightly smaller cylinder stacked on top. All right. And unfortunately, they all have different radius, so we're going to have to take the big cylinder plus the medium cylinder minus the inside cylinder. All right. So the big cylinder has a diameter of 14, so its radius would be 7. All right. And its height is 11. So we get 7 squared minus 11 for the big one. Or 7 squared times pi times 11, excuse me. All right. The middle cylinder has a radius of 5, since its diameter is 10, and its height is also 5. So minus, or plus, because we're adding that one because it's the middle one, plus pi times 5 squared times the height, which is 5. And then we have the small one that's cut out, so we're subtracting this one. Its radius is 1, but its height is the whole thing, so 5 plus 11 is 16. So we're subtracting pi times 1 squared times 16. When they do all that math, they get 648 pi centimeters cubed. All right. Now, I want to help you get started with that one just a bit. All right, you have 2 cylinders down there. All right, hints for number 5. All right, this is a right triangle. They didn't give you the height. So to find the height, it's going to be 5 squared plus the height squared equals 13 squared. Since that's your hypotenuse, solve that part for h. All right, notice 5 is a diameter, so you'd also need to find your radius equals whatever that is. All right, for 6, all right, for 6 down here, we have a triangular prism and a quarter of a cylinder. Sorry. So we have a quarter of a cylinder. All right. So what we need to do for that one, well, we need the base of the triangle, and we need the area of the circle. All right, and then we'll multiply by the heights. Well, for this triangle, we have this is 17, and that's it. For the semicircle, we know that's 8 and 8. Well, since those happen to share the same side, that's 8. We still need this side, though. So once again, we're going to have Pythagorean theorem here. All right, so 8 squared plus x squared equals 17 squared. All right, we'll work all that out and get x, so that's 289. This was 64, so x squared, I'm subtracting 64 from this side, equals 225. So x is 15, and I'm probably going to have to erase at some point here. So this part is 15, all right, which allows me to find the area of that rectangle, or triangle, not rectangle. All right, so I'm going to do the rest of this one. The triangle is blue. So the area of a triangle is 1/2 base times height, or 1/2 times 15 times 8. All right, I could take 15 at 1/2 of 8, so it just becomes 4, and 16 times 4 is 60. All right, then for me, the height here is 11. So that was my base area. Then I need to take 60 times its height, which is 11, which gives me 660, all right, centimeters cubed. And that's for that triangular prism over there. All right. Now we have the part of the cylinder. It's not a whole cylinder. All right, so we have that fractional part of a cylinder to deal with. All right, and we know it's 8 and 8. All right, so that means the radius is 8. All right, so my area is going to be pi times 8 squared, but we don't have a full circle. We only have a quarter of a circle, so we're going to take that 90 degrees over the total 360 degrees. All right, when we multiply all that out, all right, we're going to end up getting 16 times pi, all right, and that's the base area of that cylinder. All right, then the height of that fractional cylinder is 11, so times 11. All right, gives me 16 plus 160, which is 176. I'm just going to tack on the pi at the end. So we get 176 pi centimeters cubed. All right, and if you notice down here for the answer, they left it exact. So they just took that 660 that we got and added the 176 pi that we got for their volume. All right, so when we have complex shapes, we're just adding the two together. All right, whether it's like I'm doing where I'm finding the volume of both and adding together, or what the notes do where they take the areas and add the areas together and then multiply at the end. All right, doesn't matter. All right, as always, guys, if you have any questions, please let me know. Basically, find the area of the base and multiply it by the height for all your cylinders and prisms. That's the only trick that we got. All right, if there's a base that you don't know what shape it is, try to break it up into shapes that you know. So whether that's a circle, a triangle, rectangle, square, parallelogram, any of those. All right, make it as simple for yourselves as you can. All right, as I said, I hope you're doing well, and if you have questions, let me know.